Let's talk about decision making with goodness of fit chi-square tests. We'll talk about degrees of freedom, critical boundaries, and how we make decisions. We've been talking about chi-square. It's the difference between what we observe and what we expect. Now, the difference between observed and expected, not expected to be perfect, but a small difference suggests a small chi-square. And then we conclude that it's a good fit and we fail to reject the null hypothesis. But when there's a large difference between what we observe and what we expect, that suggests a large value of chi-squared. And that's when we conclude it's not a good fit and we reject the null hypothesis. So the critical region for chi-squared starts with determining what is our significance level, 0.05 or 0.01, and then finding the degrees of freedom, which is the number of categories or the number of groups minus 1. So C, number of categories. So this is what the chi-squared distribution looks like. Let's describe this. First of all, it's a positively skewed distribution because we can't have negative chi-squares. And smaller chi-squares mean that the data is consistent with what would be expected, but scores that are way out there, higher chi-squares, are extreme. And we consider that data that don't fit the null hypothesis in the critical region. So we did a candidate analysis a couple of slides ago or a couple videos ago. And the first thing we need to do is we need to look for the critical value for chi-squared depending on the degrees of freedom. So in our case, we had two different candidates. That's two different categories. 2 minus 1 is 1. So that's 1 degree of freedom. And we set our alpha level, let's set it at 0.05. So our critical region looks like it's 3.841. And the chi-square that we had determined earlier was 0.4, which is much smaller than that critical chi-square. So we fail to reject the null. There is no difference between the candidates in terms of the potential votes. So that's how we would analyze chi-squared using degrees of freedom and our alpha level. Here's from our ice cream analysis. So in this case, we had 3 different categories. So our degrees of freedom are 3 minus 1 for 2. So as we look on the table for 2 degrees of freedom at 0.05, the critical value is 5.992. And if you will recall, our chi-squared for the ice cream differences, 36.89, it was quite high. So in this case, we reject the null hypothesis and we conclude that people's preferences of ice cream flavors are not equally distributed among the 3 flavors. So let's do a learning check. Degrees of freedom for chi-square analysis is, I know we just talked about this, you really should have this, C minus 1, categories minus 1. A group of 50 food tasters were asked to select their favorite potato chip from a group of 4 new flavors. And an industrial psychologist wants to know whether there are significant differences between flavor preferences. In a study like this, how many degrees of freedom would be needed for the analysis? Well, think about it. It's 3. We had 4 different flavors, 4 different categories. 4 minus 1 is 3. So what can we say if we have an obtained chi-square of 4.15 and our critical value is 5.99? Well, we failed to reject the null hypothesis because our chi-square is not as extreme as the critical value. And I want you to just take a look and see how the notation is for chi-square. It's a little bit different. So we have chi-square, and in parentheses we have the degrees of freedom and our n equals 40. And then outside of that we have equals and then the chi-square. Chi-square distribution has which of the following characteristics? Take a moment, pause the computer if you need to. It is positively skewed. Its shape is determined by the degree of freedom, and it begins at 0. Results of a goodness of fit chi-square test were as follows. Using a 0.05 level of significance, make a decision. So we've got 3 degrees of freedom at 0.05. So if you look at the chart here, we have 3 degrees of freedom. At 0.05, the critical value is 7.81. Let's go back. 5.83 was our chi-square. So we fail to reject the null hypothesis. Results of a goodness of fit chi-square test were as follows. This time with a chi-square of 2 degrees of freedom of 9.11. We're going to use a 0.05 level of significance. 2 degrees of freedom at 0.05 has a critical value of 5.99. And comparing 5.99 to 9.11 leads us to reject the null hypothesis and say that there is a brand preference. All right, that's a very quick overview of how we find significance with the goodness of fit chi-square test. In the next video, I'm going to introduce a new test called the test for independence. It's super cool.